time. I really do think that was like that time there will go down in history, like the Manhattan Project or the Apollo Project or the Bell Labs. I grew up in this small industrial town in Alberta, Canada, raised by a single mom. So the limiting factor today, at least, it's not energy, it's not compute, it's not the algorithm, it's not the data. It's actually the people's adoption towards it. But the biggest outcomes in AI, biggest outcomes that AI will drive will 100% combine the worlds of bits and atoms.
Welcome back to the Venture Podcast. Today we're joined by Ray. Ray is the founder of Maneva. Welcome back to the Venture Podcast. Today we're joined by Ray. Ray is the founder of Maneva, and we met last summer. It's awesome to see you again. It's awesome to hear about all the progress you guys have been making. You're fresh off a huge $10 million raise as well, and you guys are ready to really make some inroads on the manufacturing and hardware spaces with AI. So, thank you for coming on the podcast.
Well, thanks for having me, Bryce, and it's good to meet you, James, as well.
Awesome. So a question that we always start with our guests is, what were you like as a kid? And we ask this because we want to understand, like, a lot of podcasts are focused on business and like strategies and these things, but it all comes to be a very good conversation when it's grounded in who you really are.
Sure. Well, I think it's a good approach. I do think that some of my childhood has shaped me quite a bit, especially even what I'm doing now. But for me, I was born in Korea, but I grew up in this small industrial town in Alberta, Canada. And for those of you who don't know where Alberta is, it's basically like Texas of Canada, big oil state. So I grew up actually like welding in the cold Canadian winter, listening to country music, drinking Tim Hortons, or like say I used to work at a semi truck shop where I was fixing semi trucks and so on. I attended a trades high school, so a lot of these kind of hands-on trades work was very close to my heart, close to my hands, and that's kind of how I grew up. Raised by a single mom, and it was a small kind of classic immigrant story that I went through. So as a child, I was always just very curious and like to break things apart, put them together. But I also love working with my hands, and all this kind of stuff. So that's kind of been my early journey.
Awesome. And that early journey eventually led you to the University of Waterloo, obviously,
That's right.
renowned in Canada. Can you tell us a bit about your experience there, what you studied? It's very clear probably why you chose what you studied, but, we'd love to hear about your experience at Waterloo and how that shaped where you are today.
Yeah, I mean, even in high school, I was basically doing like robotics competitions and I was like welding robots together, and that was a ton of fun. And so I went to this program called mechatronics engineering. So it's kind of robotics engineering. That's also where I met my co-founder, Kelvin. So we attended the university there, and Waterloo's great. I think it's a great school, a lot of bright people there. And the co-op program is also great. So that allowed me to kind of explore out to do different things. And, I usually have started around more mechanical things when I was younger, just because of my trades training background. But 2016, I was actually working in the Valley at a robotics AI company called Fetch Robotics back then. It was a pretty famous one before, started by a lot of Willow Garage folks who invented ROS. And when I was there, it was really amazing because that was also the time where OpenAI just got started. And a lot of my colleagues would go over to OpenAI and to see what it was all about, deciding if they want to work there or not, and so on. And that's also when AlphaGo came out, which is the Go playing AI from Google DeepMind that also played the first professional Go player in Korea in Seoul. So a lot of things around the AI space has happened then, including like some of the pioneering work from Google, from Sergey and Chelsea and others in the Google Brain side. So it was kind of in in terms of academics and the folks that was working on it, it was a really kind of exciting time for the field. So I got exposed to that during the co-op program of Waterloo, and I basically just fell in love with it because I was already working on control theory side of things, and I realized there's limitations with the current set of the way that we are doing these that's typically called model based. And this learning based approach was quite fascinating. And it's not that I kind of had this foresight on AI, but rather I just couldn't imagine how else these problems were going to be solved. So then I just kind of delve into it. AI was still pretty early. So at the time, I just grabbed every book that I can, replicated every paper, and I would like find one grad student at Waterloo who worked on like CNNs for like detecting fire hazards or something, and like try to learn from him and just try to learn from anybody taking a grab. So that was my journey in Waterloo, but it's a phenomenal school, and I'm very grateful for the experience there.
Yes, for sure. I have a lot of friends down here who who went there and took a similar path. Though, man,
Yeah,
I can't say I know anyone who's been to DeepMind. That's really impressive.
yeah,
And I know you were at the you were on the UK's campus at DeepMind, not the one in Edmonton, correct?
yeah. The UK is the main London office there. Yeah, that's right.
And uh, they have they have a presence in Alberta, right? As well.
They do, and basically, I don't know if you guys saw my interview with Rich Sutton,
Yeah.
but Rich, serendipitously, I grew up in Alberta, and Rich is Professor Sutton is basically a professor in University of Alberta for a long time, pioneering the reinforcement learning field. So, yeah, it was I think a great fit for opening our office there. But as far as I understand, it's London is like the main office for DeepMind, at least when I was there. Yeah.
Awesome.
Yeah, Ray. I wanted to ask next. Obviously, you got some really cool exposure. OpenAI AI is on the come up, and you're seeing all these problems that aren't being solved yet. What what sparked you to take the leap and start your own company versus continuing to work at DeepMind or other companies that are up and coming?
Yeah. Well, look, I'll first say like the time that I had a deep mind, I will be forever grateful. And I think it was such a magical point in time as well because it was really only a few hundred people when I joined. I saw work like AlphaFold going from inception to getting to Nature paper and just last year winning Nobel prizes and so on. So it was just an incredible time there. And even today, I can't, imagine a better place that I could have spent, especially during that time. I really do think that that was like, that time there will go down in history, like the Manhattan Project or the Apollo Project or the Bell Labs. I think it's just an incredible what Demis and the team there has built, especially in the early days. I think it was just magical. Uh, and when I was there, I got to do a lot of exciting work. They were very I was very fortunate that they gave me opportunity, even though like I didn't have a PhD or a master's, but they allowed me to pursue research. I got to publish first author papers, co-author on papers. So it was opportunity of a lifetime. I met my heroes. It was very clear that AI was going to become mainstream. Probably about 3 or 4 years ago, it was very, very evident that this was hitting an inflection point soon. So to some degree, I think everyone was in a position to make some sort of a decision in time of change. And for me, I think it was just that I couldn't have thought about working anywhere else just because I love the place there. I couldn't say enough great things. And only way that I thought that I could add more value to the world and learn more was starting my own venture. And to be transparent, this is my first company. I've never tried to start any companies before.
We're doing pretty
And
well so
again,
far.
sorry?
I said you're doing pretty well so far for
Well, I
number one.
appreciate it, and I do have a phenomenal team and a co-founder. But even though I had some entrepreneur spirit, I've never been somebody who was seeking entrepreneurship. So really, I this was the only company that I would have started anyways, which is bringing AI to industry that I grew up around, right? Manufacturing, the world of trade skills, and so on. I know that this industry has always been left behind, and to some degree, I thought I could fill the gap that exists because while I of course think Google and DeepMind and these companies are doing phenomenal job, I think a lot of the areas that they can make the best utilization of their technology are probably in white collar work or some of the work that we're seeing now, or even the creative space, and maybe less so in manufacturing. So, and there's technical details on why that I saw that gap. but also just a personal passion. So that's really been the driver. And so far I've been very happy with that decision, as I've learned a ton.
That's awesome. And earlier on in this interview, Ray, you mentioned growing up around this became something that was super close to your heart and also super
Hmm.
close to your hands. And you brought up
Hmm.
a super interesting point there around AI mostly being at like the software level knowledge work, these sorts of tasks right now. And like we've seen things like Chat GPT.
Hmm.
A lot of these papers with the transformer model, these things came out of Google. These things came out of
Yeah.
like things that you probably people which is pretty insane, right? Like it's changing the world today. I think we're definitely going to see like this huge push to like AI in more of the physical world, and that's kind of
Yeah.
like what you're working on. So I'd love to now maybe dive into that a little bit more. With AI, some people have said like, hey, we have the transformer model, and
Yeah.
now we have these reasoning models, and we're kind of reaching some sort of escape velocity where maybe you can scale by either increasing compute,
Sure.
by increasing thinking time of the compute, inference time, and all these different things. But the physical world is still very young. So I'd love to
That's
hear a
true.
little bit more about how you're approaching these models, and like what do you think needs to happen in order for us to see the same sort of traction that we've
Hmm.
seen in this knowledge work with AI into like the
Hmm.
physical world with AI? What's missing right now?
It's a very good question. And I think you're touching on a few things. So I'll try to address some of those things as well. So I think one of the things is what we're seeing out in the world right now. The second thing that I'll kind of uh, look at a like 50,000 feet level, which is how big is this AI thing and where is this going to take us? And then the last thing around the physical component and why, and even just a motivation for why should we be focusing on the physical world when it comes to AI. The first bit, I think I have a little bit of contrarian view on this, where um, putting aside all the discussion for AGI or compute and all this stuff, the current models that we have just now are already just incredibly powerful, incredibly powerful. And if you think about the impact that these models can have, let's just think about the maximum impact that these models can have in the world in general. Maybe it's the world GDP or world's economy in some way. It hasn't even hit where it should be hitting in terms of the capability versus the impact. So the limiting factor today, at least, is I actually don't think it's not energy, it's not compute, it's not the algorithm, it's not the data. It's actually the people's adoption towards it, right? How people are able to adopt and learn about AI is the biggest limiting factor, because it could do so much already, but it's not doing all of that. But it's only because of you know people's willingness to adopt it. And that's been a big lesson for me as well, where I've used to think about things as a technical challenges or scientific bottlenecks. But I that's my view right now, seeing a little bit both as coming from the research and also on the adoption side. I think it's a lot more to do with people's adoption. Now that curve will move very, very fast, and I don't think it's going to be the biggest bottleneck for a long time, but currently I do think it is. Now, where I think about the timelines, and you know, if you watch any of Demis's talk, which I highly encourage,
Yeah.
he
Demis
really,
Abbasis, could you give a
yeah,
quick snippet about Demis, just so the audience can know?
yeah, sure. I wouldn't do him justice, but I believe when he was young, he was basically a prodigy in chess. He was like one of the youngest grandmasters. He went off to later build game studios, which is super exciting. So I think he has a lot of creative aspects as well. But then he studied neuroscience, and then eventually started DeepMind, with an understanding that this kind of deep learning and reinforcement learning model will actually bring AGI at a time where I think nobody even understood what AGI was. And I believe it was actually coined by Shane, who's one of the co-founders of DeepMind as well. So that's a little bit of background on them. As I'm a big fan, obviously. But I think one of the things I'm very grateful for to Demis is Sir Demis, I guess now, and the Nobel Prize winner, is that I think, really emphasizes this understanding of root node problems and how big this thing's going to change the world. And this is my interpretation of it, which is that, and how I take it in is that I do genuinely think, especially after going through the DeepMind experience, that AI is going to be bigger than the internet, the smartphone, even the electricity combined. And the reason why I think that is because if we kind of go back, if you guys ever seen those curves where the population growth like goes skyrocketing, And if you go back to where the inflection point was, it all started with the Industrial Revolution. And the actual invention that kicked it off, I would say, is the steam engine. And before the steam engine, basically all physical work was done by biological muscle, or 99.99% of it, right? Whether it's moving things around or picking this up or mowing the lawn, whatever it is, it's all been done with biological muscle. Now, then the steam engine came in, and all of a sudden, in the next 200 years, which is kind of the era that we live in now, there's nothing that hasn't changed. If you look around yourself, the headphone that you're wearing, the sweater that you're wearing, whatever it is, everything that you see around you has changed fundamentally because we were able to create artificial way of doing physical work using energy. Right? We're able to convert energy into useful physical work for the first time in human civilization. And that changed absolutely everything in the span of 200 years. Right. And now today, I would say 99.999% of any useful for physical work is artificial or energy based, right? Trains and planes, all this stuff. So if you think about that, where are we today? Today, 99.999% of intelligence in the universe is biological. Okay. And for the first time, we have an artificial form of intelligence. And if the physical industrial revolution took 200 years to change everything that we see around us in ways that it will be impossible to connect the dots when you were 200 years ago, but we can connect the dots now. The digital revolution, or I would call it the intelligence revolution, is only going to happen in a shorter time horizon, 50 years, 100 years at most. And it's going to change everything, where in that time, after that, 99.999% of all intelligence in the universe is going to be biological. And I'll just end it off with saying that I do think that you, I, all of us, as well as people who are working age right now, are the most interesting generation in human civilization, because we are going through pre and post AI, right? When we're born, AI didn't really exist. But as we go into our career, AI is going to fully transform the world as we know it. And what's kind of funny is that, and I hear this from even our customers and other team members, is that the kids that are born now are totally going to take AI for granted. Like, of course, this thing should do everything for me. Like, why am I even bothering to do this at all? It wouldn't make any sense to them. To some degree, the direct work that we grew up around doing, to some degree. So that's my also kind of belief on how big this AI is. So I'll keep the last part brief, which is that 60% of US GDP is in the world of physical operations, and 40% of global GDP is as well. So if this is going to change everything, right, the half of the world, right, and more than half of the US economy is in the physical world. So there's no way it's not going to change. And I actually think that it's very difficult to see it now. But the biggest outcomes in AI, biggest outcomes that AI will drive, will 100% combine the worlds of bits and atoms.
Well, and I'm curious too, Ray. Like you did say, there's going to be major tailwinds for the generation that's born today, but then also people who are entering the workforce now, especially like a lot of our audience is new grads and students who would typically go into a traditional career path, and career paths are going to look a little different over the near term. So I'm curious, like what would your advice be to students who are curious about AI? They want to learn more, they want to expose themselves to the leading cutting edge of AI. How can they experiment themselves, and what can they do to position themselves to have a successful career?
Yeah. So I'll just be transparent that like whenever I give like whether it's a speaking event or other things, like I always get this question after, and I am very careful with advice because I'm no one to give an advice. Everybody's path is different, so take a huge grain of salt of what I'm about to say. But because I've heard this very often, I think where I kind of come to a consensus on is I think people that are young and ambitious and eager to learn, they don't have to worry about all this AI news and the world taking jobs over whatever. And I don't think it actually changes the strategy of what the best artists, the best creators, and best inventors has always done, which is to use the best tools. So I would say like it doesn't matter, if your passion is in the arts or the creatives, creating great movies, great films, or creating startups or whatever it is that you're in, or creating great, baked goods, whatever it is, and or manufacturing for that matter, right? Just to give a little plug. I think there's no way you're gonna change your passion because the world is changing, right? So you should follow your passion, the thing that you're curious about, but try to utilize some of the newest tools that's coming out, right? If you are a filmmaker, maybe you should check out some of these video generation models just to get inspiration, right? Just to make that more efficient or just to try something new, right? And I do think that creativity is really important. And a lot of these AI tools are just going to able to help you get better creativity, think better, visualize better, but at the same time, I think do a lot of the things in a much, much more efficient way. And that goes same for our customers who are manufacturers, right? What should they do? They should use the best tools and a platform for manufacturers, specifically for manufacturers, but that's AI native, right? So I think just using more tools with things that you already love doing, I think that's the best way that I think I've always gone about it, and I hope that some other folks can experiment and create incredible stuff with in the future as well.
Yeah, that's really good advice, Ray. I know a lot of our audience will like that, especially since they're super young and trying to figure out all this stuff and navigating the crazy world of AI right now. But I wanted to dig back into Maneva, obviously, and hear about. So you leave. I just want to get the story of, you left DeepMind
Yeah,
to go start Maneva. How did this all of a sudden go on this crazy hockey stick trajectory? Like, what was, I
yeah,
don't know if you want to walk me through like your most memorable moments of growing the
sure.
company, whether that was fundraising or actually building the product. What kind of sticks out to you there?
Yeah. I mean, I think at a high level, we started with this almost just an intuition of what happens if we were to bring video AI from something like a self-driving car to manufacturers. What would manufacturers do with video AI that's powering something like a self-driving car? And we honestly just spent the first year just learning about the industry. There's literally pictures of me and Kelvin sleeping on factory floors on a cardboard, um, at like 4 a.m. to see what happened during the night shift and the turnover, like many, many, many nights. Sleeping in the car, like all those kind of stuff. And I think that was a really important moment because we really tried to learn what the industry cared about and not to come in with a prescribed product, but rather uh, just a learning mindset. And even in the early days, and even now, the approach that I'll take with engaging with customers is, look, you're producing these things. I love the products that you're producing. I'll just love to learn more about how you're producing these things, right? And what are some of the challenges that you face today? And today, those things are quality, labor, downtime, and safety. And these are the four KPIs that our AI agents are able to power. And Maneva today powers video to action AI agents that's amplifying continuous improvement across these four vectors. But the pivotal moment there in the early days was just spending enough time with customers to understand the things that they care about. But at the same time, I think what makes us really different is because often people will compare us to, let's say, their company, like great companies like Keon's or Cognix, were more, I would say, camera and traditional computer vision companies. But there's also companies that are more on development tool side, targeted at AI engineers or AI developers to create models that's more factory agnostic. And what we realized that our customer base are really the frontline workers of our generation that keeps our world moving and produces the goods that you and I all depend on to survive. And transparently, the last thing, and I should have already known this from the industry that I grew up, but the last thing that they want to do is get another dashboard, learn how to use yet another software, and deal with something that gives them overload information rather than actually going and doing the work. So that's one of the, I would say, big pivotal moment for us where we realize that it's really about these AI agents that for us, we call it the physical API layer, right? If a ChatGPT API is able to interact in Python and give out different prompts and answers and outputs, for us, we have a physical interface that's universal for our customer base that they know how to use. Just like a software engineer knows how to use an API, one-liner API, they know how to use that. They know how to use our technology. And I think working very closely with our customers has been like the biggest driver in what's been critical to, I would say, very early success that we are seeing in the market, but certainly just an incredible amount of demand that we're seeing out there.
Got it. Very cool. And Ray, like what made you really want to start with these video to action models, this sort of thing as an initial beachhead? Because I would imagine you, as someone too, like you, this is what you grew up in. There's probably a lot of different paths you saw to start, integrating AI here. So
Oh,
why did you choose this one to start in terms of like, the four key things you mentioned, really
yeah.
focusing on quality assurance and safety and compliance and these sorts of things?
That's a very good question. I think there's two components to it. One was that the manufacturing industry was already while it is quite automated, it is still labor intensive. It is quite labor intensive. And if you think about what that means, it means that there are people who are looking at things with their own eyes to do some form of work. And today, it's not like the headphones that you wear or the spoons that you eat with or whatever. They're not crafted actually by hand, right? They're crafted by machines. They're punched out by machines. So really, a lot of our customers and the plant operators, they are on the line that is monitoring and making sure that these equipments runs properly, and it's more of a management layer almost to these massive equipment. Because if you think about a factory, it's just a giant machine. It's just one giant equipment, and there are people in there to make sure that things run well and properly, right? At every single process and what we call junction points. So a lot of that is already done through vision and human intelligence. So when I thought about that deeply, and almost a question, why didn't the previous promise of computer vision in manufacturing or even IoT in manufacturing didn't take off? It's because it had the false promise based on abundance of cameras. It had the initial excitement around abundance of cheap sensors and cheap cameras. But what was missing was the abundance of intelligence, because you could give these folks million different cameras, million different sensors and data points, but they're already running out of people to be able to run these factories really, really well. And with the lack of intelligence, it made it just basically a successful example would be something like a security camera where it's like monitoring and recording things, but not actually doing a real physical work at the operation level. But that's what really our customer needed. So when I thought about those kind of both of those things, that hey, if we have abundance of intelligence, which was evident from what I was saying, and also the fact that still today people are utilizing their intelligence a lot actually in these manufacturing sites to make sure these equipments run properly. That was kind of the initial aha moment for us. And then I'll also take a step back and talk about that the analogy that I brought up with self-driving cars, where today almost like traditional technology, whether it's traditional sensors or computer vision, you can almost think about them like a self-driving car that only knows how to drive in one block or one set that's really custom set up for that car to drive. And while that has some use cases, right, the use case for it or the usefulness and the value for it doesn't compare to a self-driving car that can drive on the actual roads that we've built. And that's what our customers face today. They have factories already, or the way of making factories already, and the technology need to adopt to the factory rather than the opposite, the other way around. And that's been the biggest challenge. So for us, it was very key that we develop that core video AI agent that takes actions autonomously, just like a self-driving car would, that's able to actually drive it on the plant floor that our customer needed. But then the next step, so just to be clear, this is our video to action AI technology, and it gets powered in a couple different things called Vita and Alice, which is different use cases. But we have another layer called Kaizen, which sits on top. And you can think about all these little video AI agents that's doing different things, automating different workflows. And there's Kaizen that sits on top. And you can almost think about that as a self-driving car is super useful, right? It drives you around. It's great. But what if the self-driving cars can start talking to one another and orchestrate? Now you can all of a sudden solve all traffic jams and all accidents. And that's where Kaizen AI is. But you can't build the Kaizen AI. You can't build that fleet AI without the actual self-driving model. And for us, our video to action AI agents.
That's so cool. That's so cool, man.
For sure.
I guess the thing is, a lot of this stuff to us, it feels very new. Like, learning about like these architectures. From the LLM standpoint, I almost think of like, okay, maybe it's like a mixture of experts with like a routing model on top,
Sure.
or maybe you have some orchestration model on top with some child module or some child, smaller models that are doing specific tasks. Like this all feels so new. But you probably had a very inside look at like, hey, this isn't so new because this is maybe something you were able to see like earlier on. I guess like again, like how did the access you had early in your career to like things like DeepMind, places like these really help so you can be at the forefront of what you're doing now. So
Yeah.
when the world is making these orchestration level models with software, you're already doing it with things like hardware.
Yeah. Uh, I'll almost answer it slightly differently, which is that it almost taught me what not to do. So I would say, so there's a concept of like one-way door and two-way door. I think Jeff Bezos made it pretty popular on like there are decisions that are two-way doors where you can go back on it, so just execute quickly, essentially. There are one-way door decisions where of course it's reversible. It's very difficult to reverse. And we of course had some of those. And one of the ones that I that comes to my mind answering your question here that was very important for us as well is that if you remember, and it's kind of crazy, but if you remember a couple of years ago, like I say 1.5 years ago, a couple of years ago, almost every single company said that they're a foundational AI model company. Everyone was building foundation models. And I know some of them done well and some of them maybe not. I don't really know exactly. I don't keep track of all of them, but it was definitely a major focus, and then I would say almost what was really hot at that time. And for us, we had a similar decision to make on like, hey, do we want to be a foundational AI model company for manufacturing? Sounds cool. Sounded like that that will attract investors. All this stuff. But when I thought about it from just first principles and what I knew about the technology, one was, and this is going to be different for every company, but the actual intelligence as it is right now comes from massive data on the internet or massive data that's basically available to everybody. Okay. Not domain specific knowledge. As in, like, if we wanted to create a best video AI agent for manufacturing data is not going to get you that intelligence. It's the general intelligence that you need to have, and then you need to fine tune things on top of it. So even though domain specific data is very important, but that's not where majority of the compute to intelligence ratio is going to come from. The compute you want to spend most of the time pre-training these models. So that was one anchoring of how the technology worked. And then the second thing was, I wouldn't say it was super obvious, but I was comfortable making the bet that most of these companies are going to start to open source their models, especially the smaller ones that we needed to run on the edge. Because we run our AI just like self-driving car. You don't want a self-driving car that is dependent on the cloud, where the internet goes down and it just doesn't know what to do. So in a similar vein, we knew that was already obvious from our architecture standpoint. And for me, I was very comfortable making a call that, hey, I don't know who it's going to be, but these guys are going to start publishing these models as open source. There's going to be a big open source aspect of it. So if you combine those things together, it was very evident that, hey, we're not a foundational AI model company. In fact, our key technology, and this is something that I talked about also at Professor Sutton's podcast, is around the reinforcement learning that helps fine tune these models to be domain specific, right? And I also had a bet that reinforcement learning is gonna be back at the center stage of importance. So it was really almost convenient when I was telling this kind of story, because this kind of story our customer doesn't need to know about, but our investors do. So when I was explaining some of this stuff, basically as we're going through our, fundraising cycle, OpenAI just came out with, oh, we're going to be doing reinforcement learning from human feedback, or reinforcement learning that was more focused on fine tuning. I believe they like literally published that
Yes.
some of the week that I was talking about this end of last year. So some of those things has helped a lot in just almost one, knowing what not to work on, just knowing the technology first principles. And second, I guess getting ahead in terms of where the next big thing is going to be on.
Awesome. Awesome. James?
Yeah, Ray, you also you talked a second there about, your fundraising and how you had to convince VCs that AI factories were the future and could scale as well as LLMs. So I'm curious, what was that experience, the first conversations with VCs to convince them that this is something that will be the future? And what
Yeah.
did those conversations look like? And were there any doubts after some of those conversations?
Well, look, I think every fundraising process, to some degree, you get a lot of no's, and that's totally okay. And to some degree, I think no's from both sides as well, like just not the right fit, and that's totally okay. And we're very grateful with the investors that we have today. But I think every fundraising story is very different. And again, for us, it was also different, where we got very, very fortunate, where we almost kind of got semi preempted, as in like we were actually going to raise earlier this year, but serendipitously, I was in SF for other events and stuff around September, or basically like Q4 of last year. And we kind of, I just had general catch-ups and so on as I was, visiting. And some of the momentum just kind of built on its own. So we were very grateful where the momentum was kind of organically built. And we were kind of just basically saying, hey, look, there are people who are interested in participating. So I think we're going to move up the timeline if folks are interested. And then we met with a lot of different investors. So for us, it was very, very, we're very, very fortunate. Now, when it comes to the story and the narrative, I think one is that I talked about this Kaizen and video action models. And I would say the immediate vision for us is that I'm sure you guys heard about like lean manufacturing, just in time, Toyota manufacturing, Lean Six Sigma, continuous improvement. So this is when I would say this concept has brought incredible abundance to America and the world. I would say this is probably the most valuable process methodology, or just methodologies in general, that we've ever seen in history, because it allowed us to manufacture things in a way that at an efficiency that we've never even imagined before. To be honest, that's the reason why all of us are living quite abundant lives in terms of not having to worry about a lot of these what we call today commodity goods. But it was really based on this concept of continuous improvement. Kaizen is the word for in Japanese, and it's such an important concept and methodology. And for us, our vision is that our Kaizen product, basically the next generation of Toyota manufacturing, Kaizen, continuous improvement, Lean Six Sigma, is actually going to be powered by AI. So even the inefficiency that's left over in manufacturing today, right? Let's call today's OEE, which is overall equipment effectiveness, which is kind of like a high level efficiency metric for manufacturers, would sit somewhere around 60, 70%. We're going to start to see 90+% in manufacturing efficiencies that the world has never seen before, right? And basically manufacturing is going to be almost as efficient as big tech companies today in terms of their operations, when it's powered by AI continuous improvement. So for us, that's the 5-10 year outlook on why this technology is going to transform one of the biggest industries in the world. The second aspect is that it's going back to the root node problems. Of course, I'm an incredibly ambitious individual, and I care about solving the biggest problems in the world. And if you think about a root node problem, I do genuinely believe that manufacturing is a root node problem. And what I mean by that is in the next 10, 20-year timeline, we're going to have AI that's going to discover new manufacturing methodologies. Okay. There's something called the Bessemer process, which, if I just kind of paraphrase, it's a way of making better steel, I believe, by blowing some air into the actual production cycle so that it crystallizes in a better way. And that kicked off the entire steel industry uh, as we know it today, and about 100 years ago or so. So that one methodology has powered all of steel production that we've seen in the last 100 years. A way to make better steel, a science behind making better steel, right? Imagine that we're able to capture all of the data in manufacturing, how things are just made, right? Whether it's chips to steel, to plastic, to food, right? So imagine all the possible discovery that we can make there, right? Just like I mentioned, 99% of all intelligence in the next 50 to 100 years is going to be artificial intelligence. By the same token, basically all of the discovery, scientific discovery, is going to be discovered by AI systems in the next 10, 20 years. Now, if you think about where are some of the areas that can, be the biggest outcomes for humanity when it comes to discovery, I would actually say it's manufacturing and production. Because if we know how to make the top percentile of steel every single time, or top best chips every single time, that'll fundamentally change the way that we think about the world, abundance, as well as material science and almost every single scientific field as well. So that's kind of the bigger, I would say, humanity mission that we have as Maneva, that we're not just developing technology that's going to, make manufacturing more efficient and autonomous, but this is the technology and the bedrock in which we're going to discover new manufacturing process methodologies in the next 10, 20 years.
I think that's going to be an incredible future, by the way. And from an optimization standpoint, it's going to be huge. I guess the other part of that too is then, okay, then AI is going to observe and it's going to allow us to do things in a better way. But then, as you mentioned earlier on, there's also just going to be like this brute force scaling in terms of like the raw number of things, like the raw number of, whether it's humanoids, whether it's
Yeah,
robots that are doing these tasks, like the output
sure,
can be so much more. So I'm kind of curious. You mentioned today there's going to be kids who are born today and they're going to have no idea because they're just going to take
sure,
these things for granted. Um,
sure.
how do you view, like, in the coming years, let's say, like, 20 years from now, what do you think, maybe 50 years from now, because I think hardware will, these things take a while, but what do you think the world will look like capturing perspective, and how will it
Uh,
affect everyday people's lives?
well, uh, I'll say, look, manufacturing is definitely going to become faster, smarter, and safer. So I do think that's going to be one of the biggest things that we're going to be seeing, which I think is something that will make my team incredibly fulfilled in what we're doing. So I think it will see broad spectrum improvements in all those different dimensions. But if I'm being transparent, I think no one really knows. No one really knows, because if I were to go back and then we had this podcast when let's say we have the steam engine come out and then we had this podcast, could we have imagined that the steam engine gave rise to better precision manufacturing? That also gave us rise to discovering electricity and manufacturing different electrical components, give a rise to computation, and then giving rise to energy discoveries, and then giving more rise to information age and the AI age. I don't think anyone would have been able to guess that. I mean, that trajectory is just so not obvious, right? So not obvious, because there are almost near infinite paths that could gone about. So we know, I think, what it looks like in the short horizon. But I think, to some degree, I think it's just very important to stay grounded and just work on the actual factory floors with the folks that's needing it and just making their lives easier. And I think there's that level of humility. I think it's great. I think it's actually wonderful. I actually love saying that we serve our customers, right? That's what we do, right? And to some degree, everybody serves somebody, and that's totally okay, right? And I think that I think, you know having that humility around, hey, we don't know a lot of this stuff, and God knows that basically we don't know how our manufacturers they're good in their specific domain, and we can't learn all of them either, right? So we're there to make their lives easier. At the end of the day, we're a business. We build product and services to make our customers' lives easier, and want to just ground ourselves in that. It gives us clear direction on where we need to head today. And I know we can't connect the dots looking forward, but that will inevitably get us to the right place that we need to. And I'll end it off by saying, and this kind of goes back, and you guys can cut this out as well, but basically, you know, it's a bit of a cliche example, but when the iPhone first came out, no one in the world, I think, expected the biggest outcome of the iPhone to be the disruption in the transportation industry. And what I mean by that is, if you look at by market cap, the biggest outcome that iPhone created was Uber. Facebook existed before, Airbnb existed before, and basically it's the combination of GPS, 3G, and having software in this mobile platform that enabled Uber to exist, right? But I think it's not just the technology part. It's also the fact that one, Uber combines the world of bits and atoms. So it captures the whole GDP, or the big markets that we really need to care about. But two, I believe probably before Uber came about, there are probably about 0 person in the world who said, "Wow, I love that taxi service. That taxi experience was phenomenal." So it was also tackling an industry that was quite left behind in technical adoption. I would imagine if the taxi industry was actually further ahead in technical adoption, the Uber wouldn't have been the biggest outcome it has that we see today. And largely, I think about the manufacturing in a similar vein, where, or all this world of physical operation. It's an industry that now can leapfrog because of AI, because we actually can do autonomy, real useful work for our customers. So I do think that from a more of an analogy standpoint, I do believe not just, manufacturing is going to change over time. I do genuinely believe that manufacturing industry is going to be one of, if not the biggest outcome from the AI era, which is a bit contrarian and ironic thing. Not ironic, but like a bit contrarian and like to think about. But certainly no one predicted, I think, the transportation industry to be the most disrupted with the iPhone coming out. So
Yeah. I guess from a bit of a technical perspective now. So I'm curious a little bit about like the AI that you guys are using. I know you said video to action. Are these like are these more ConvNet based? I'm assuming it's not LLM based. Do you see leverage of LLMs as well? And maybe you could even say to our viewers who are not familiar the difference between these technologies and like
sure.
why both of them are important and how AI looks
Yeah.
very different. Because we've all seen ChatGPT, but the truth is AI is way bigger than that.
That's right. That's right. I think it's a good way of framing it. And I would say, like, for us, we are truly like a AI company, an AI native company. And the way we define that AI native is basically like, if you were to take the neural net out of your product or services, what's left? Like, for example, let's say there's AI powered services. If you take the AI out, it's just less efficient. Maybe the recommendations are worse and whatever, but there's still functioning product. If you think about something like ChatGPT, if you take out the model, you're just an empty chat thing. There's no product left. So that's what I consider to be AI native. And for us, that's a core value we present. And we are also basically hardware agnostic. So we can use any cameras, any PLC, any integration, and so on. In the same vein, we are model agnostic, right? We basically are the fine tuning layer and the Kaizen platform layer rather than the model itself. So we are basically agnostic to the model itself. So, if I can explain a little bit about these models, basically there's a couple things that you're pointing out in different dimensions. One's around the architecture. Architecture meaning, well, how is this AI model wired up? Does it look like a ConvNet, which you can think about as a convolution, but almost think about like a funnel type of approach in processing the data, or let's say a transformer, which is trying to look at a lot of different things and paying attention to different parts of the context at the same time, or the input at the same time. So that's around the architecture side. And there's the other side, which is around modality. Modality meaning, what is the actual communication channel that you're using? right? Is it language? Is it vision? Is it video? Is it audio? And what are you outputting, right? So those are the two, I would say, apart from the size of these models, two dimensions that I think are really, really critical. And on the architecture side, I think there are differences between, a large ConvNet or a transformer, a vision transformer, and so on. But I do think that the lines between them are getting more and more blurred, and we're also seeing a lot of hybrid models and so on. And we'll also see a lot of different models that will overtake the transformer, but probably also take a lot of lessons from it. So from an architectural standpoint, um, I think we're seeing a lot of flexibility, and it's not where we are super opinionated on, right? If it's a ConvNet, that's fine. If it's a transformer, vision transformer, that's fine. Whatever model architecture that fits the performance metric, that fits the inference time metric, I think is ultimately what we care about, and it's learning capability. Um, Now, on the multimodality side, yeah, that's where I would say we are both having, let's say, video only or vision only models, but also vision language models. And you could ask yourself, well, what does um, what does language have anything to do with understanding the real world? And again, I would kind of um, take the other side of it, where if you think about something like a self-driving car, right? And if you needed to teach it around what path that you need to go on, maybe all you need to do is show that path via video, and that's all you have to do, right? But if you were to tell it to, let's say, not do something, right? Let's say, don't go here, don't go there, don't go in direction, and so on. There are basically million different ways that you could basically do a bad move, and that's much more efficient to communicate via language. And in the same way, let's say if I wanted to, maybe you're trying to teach me a dance move or something. It's very difficult to describe that in language. You kind of have to show me how it works, right? But when I want to, describe, let's say, something that I like, or some taste that I like, or something like that, it's much more efficient for me to describe you what kind of cuisines and so on and that I like, rather than just trying to show you a whole bunch of images of Korean food, basically. So that's, so what I'm basically saying there, for, I would say, kind of just general folks that are out there, is that different modality allow you to communicate with our AIs in a much more efficient way, just like we do with people. So that's one of the reasons why multimodality, I believe, will be universal throughout all applications. For technical folks that are out there, this is something that I would kind of use hand wavy math terminology for now. But if you know something like a dual space problem, where basically there are things where it's much, much more efficient to do it in one dimension, one space, or one manifold rather than another, where, let's say, some problems are intractable in one, but it's very tractable in another. So some problem are, let's say, non-polynomial in one, but it's polynomial in the other, into compute time. Like you can compute it with O1 in this way, but it becomes like O(n) squared or exponential or whatever in another space. Very common. Or you see very similar type of approach giving a rise in two different areas, like LQR, for example, in control theory, and Kalman filter in, let's say, fusion. So there are things that happen at two different type of spaces. And if you are able to utilize both spaces to support, let's say, this distribution or set, it basically allows you to solve the problem much, 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 much faster. And I think that is actually going to be fundamental in what we're going to see with generality that's shared across, let's say, vision, language, audio, all this stuff. It's because some problems are just much, much, much easier to solve in a particular domain or modality. So I do think that's going to be something that we are at least very, very bullish in. And that's what I would say. The same thing, we were very bullish in reinforcement learning from day one. It's core of our technology and active learning. And multimodality, I believe, will be a central piece to almost every single AI applications in the future, including us.
For sure. And I'm kind of interested as well, from the perspective of like, we'll have a lot of viewers and friends who are in many different industries, and maybe they're not as technical. They probably won't, they might not be the ones who, are making these models, but but they understand their data very well. They understand their industry, and they want to start to leverage this sort of stuff. Where do you see the world going, and what sorts of tools do you think maybe that are here right now that, other than ChatGPT, that people can look into and leverage and really accelerate their own careers or accelerate their own passions? I'll phrase it as a passion, because I think that's cool too.
Yeah, I think it's two different uh audiences for that. One is for folks that are individual who have their own passion they want to create. And I think those people, to be honest, know what to go for. They know what they love. Let's say, they're a musician or they love producing music, right? They know where to look when it comes to all the forums and people are talking about these things. And I would say as long as you're open-minded in trying these tools out, giving them a shot, that's already, I think, 90% of the job. Because your crowd, the people who you're with, will already be thinking and talking about it, just like you and I are talking about it. So I think for individuals, it's just as long as you're open-minded and trying it out, and trying it out has never been so easy, right? You could probably do it in an afternoon just to get what it looks like out. And, if you go back 2 years, it would literally just be typing in hello to ChatGPT that day, right? Just on the day that you heard about ChatGPT, why don't you just, show it something, send it something, and just see what happens. And if you don't like it, then come back or don't worry about it. But I think that already takes 90% of the way there, because the technology is already so magical. Like, we have a magical technology that's coming into the world right now. So I don't actually think you have to do a lot other than just to try it as an individual.
Just use
Now,
it. And that's kind of what you were saying earlier in terms of like
yeah,
biggest bottleneck is just adoption. Like, people just try this stuff out.
that's right. And look, I hesitate on giving people advice because everybody's path is different. And for me, I would say, like, I've never been the smartest guy in the room, or I've never been this, the fastest person in picking some things up or something like that. I've always, I think, taken my own path at my own pace that I think mattered. And I think in a similar vein, I think, trying to be perfect with all the tools that you use or the way that you go about just has never been my style, at least. I think it could work for some people, but it's just never been my style. So in the same vein, I think it's just like, give it a shot and see what happens and be open-minded is, I think, all that I needed at least to get to the grateful success that I have today. Now, I think for businesses or enterprise level customers, it is a very different question. Because I would say there's two things that you need to know for AI is, one, you don't have, from a business standpoint, what AI should mean for you is an immediate ROI. Okay. It needs to be it doesn't need to be a 3-5 year plan on implementing across the board. It should give you immediate ROI, because that's what this technology does, right? Yeah. When you think about a self-driving car product, it should drive you from point A to point B, right? Yes. You're not going into a self-driving car thinking, oh, I got to learn a new software and look at a new dashboard like that. You get in the car, it takes you somewhere. That's what AI is. You get in, it should take you somewhere. Now, I'm not saying it's going to be perfect. It might make some wrong turns, but that's the whole point of it. So I would say evaluating services, products, and companies in utilizing AI, one, it should give you immediate ROI on something, workflow, or thing that you really care about, the main thing. The second thing that I'll say in that vein is, I do think it's important that you, at least for something, the thing that it's really important workflow, the thing that where you have the biggest ROI, you focus on partnering with companies that's dedicated to that space. That's dedicated to that space. Because I'm not saying that, you should use, Gemini, ChatGPT, all this stuff as a general tool and so on, right? Let's think about them as more like productivity tools like Microsoft Word or Google Docs. But there are things that a tool that's super useful for your industry that you need to work on the main thing that you care about the most. And those, I think, should come from a partner, a product organization that has a taste that's dedicated to your industry. I just thought about this the other day with a friend of mine, where if you think about messaging, just in general, like sending messages, it's just pretty simple concept. You send a message, you get a message, that's it. But we have Slack, we have Teams, we got Messenger, we got WhatsApp, we got all these different things with even the slightest optimization on different audiences, different use cases, and different context, right? And those are the same with the call that we're on. We're using some software to do a podcast, right? Rather than Zoom or rather than this. Like, there are dedicated tools that's meant for specific industries and specific audiences that just works way better, even at the slightest margin. So those are the two takeaways that I think businesses that I encourage to think about, at least, is that one, AI means immediate ROI. You get into the thing, it should take you from point A to point B. Second, you should be partnering with companies, especially if it's a main critical thing for you, that are dedicated for your industry. And that's why for us, we don't think about ourselves as computer vision or even video AI or optimization service, but rather we are a mission critical AI platform for manufacturers and manufacturers only.
Yeah. Awesome, Ray. I want to wrap up the podcast here because we have to go, but I'm really glad that we got to talk. Like, I think you have an incredible story, right? Like, you've come a very long way from that semi shop in Alberta. So for what it's worth, I'm very inspired by your work and the journey you've had. I wish you nothing but success, going forward. I'd love to, follow up with another interview in 3 years' time when you're absolutely running the entire manufacturing game with AI, because I think it could happen. Yeah, awesome advice, awesome technical insights, just awesome guidance in general. So thank you so much, Ray. I really appreciate you taking the time to talk to us today.
Amazing. Well, likewise, thank you so much for having me.